Good morning, Algebra 1. We are on our final day of notes for scatter plots. On Wednesday, we'll be working on a project using Desmos, just like with what we're practicing today. So what you need to do first, if you have not already, is just like we did on Friday, you need to go to desmos.com. And you need to click Open Graphing Calculator. And it should look like this screen. Give you a second to do that. You also should have your notes packets open. All right, so number 1 says, Table 1 shows the data collected by the local urgent care over the course of 6 months, comparing the number of sunny days in a month to the number of cases of severe sunburn seen in patients. We need to find the line of best fit and eventually the R value. So to do that, we're going to enter this table in Desmos. So once you're on Desmos, remember you're hitting the plus sign, and then you're selecting table. And then we're typing those values. Once you have all those numbers typed in, I'll give you a second just in case you're doing that, but remember we can't always see them right away, and I'll remind you how to find that. It's also in your notes. It has a list of everything, all the steps to getting the line of best fit and viewing the graph for this data. All right, let's take a look. So once you have that data entered, we're going to hit the little magnifying glass, and that's going to show us our data points. And then to get the equation of the line of best fit, we hit that line with the dots around it. All right, so it looks like the line of best fit is y equals, let's round to 1 decimal place, 2.7x minus 40.1. Oops. And once we write that equation, we need to interpret the slope. Remember, look up at the board, and I have those sentence starters to help you. So to interpret our slope, what is the slope telling us? Well, it's telling us that the cases of severe sunburn because our slope is positive, that means they increase by 2.7 for each our x variables number of sunny days, so for each sunny day. Once we do that, we need to write down the R value. I'm going to switch back to Desmos. Remember, we're looking at the lowercase r, so that's going to be 0.93. how would you describe the correlation? Well, if it's 0.93, that means it's strong, positive, which means as the number of sunny days increase, the cases of severe sunburn increase. All right, letter D says, the weather forecast predicts 20 sunny days next month. Predict how many cases of severe sunburn that the urgent care should be prepared to help treat. So remember, sunny days is X, which means we're plugging in X equal to 20 in our equation of line of best fit. So Y equals 2.7 times 20 minus 40.1. And I'm going to type that right into Desmos. So 2.7, times 20 minus 40.1 gives me 13.9. All right, letter E says, after looking at the data, the urgent care decides that they should look at next month's weather forecast to decide how much skin cream they should order to help treat infections from sunburn. Do you think this will work? Explain. I'm going to give you about 30 seconds. I want you to decide, do you think this will work? Could we use this data and the number of sunny days next month to figure out how much stuff they're going to need to help cure the sunburn? All right, based on this, I would say yes. The number of sunny days does help predict the number of people with sunburns. Based on this data, because we have a strong positive correlation and because sunny days are what cause sunburns most of the time, we can use that to figure out how much skin cream they're going to need to cure those sunburns. All right, when you're ready, you're flipping to the next page or flipping your packet over. And we're also going to go back to Desmos to enter our new data. So you're going to Desmos. And we're going to clear out what we had before. And you're typing in these new values. And I'm going to do the same. So I'm hitting the X on everything I already had typed. I'm hitting the plus, and I'm adding a table, and then I'm adding my values. Oops. Make sure, I'm going to do the same. Make sure when you type those values in, you double check that you filled them in correctly from your table. Okay. And then once you do that, we can't see the points right now, so we hit the magnifying glass that zooms and fits the data to our graph. And then we hit the line with the dots to get that equation. So here we have the equation y equals, let's round to 2 decimal places, 0.57x minus 94.6. And we have an r value of 0.86. So this time we're looking at, it says, Table 2 shows the data collected by 6 different Kroger stores during the month of July, comparing the number of ice cream pints sold to the number of sunscreen bottles sold. So we got the equation y equals 0.57x minus 94.6. And we need to interpret what this slope means. What is it telling us about the data? Well, it's telling us the number of sunscreen bottles sold increases by 0.57 for each pint of ice cream sold. Then we need to figure out what is the correlation coefficient. And you can look back, remember you're looking at that little r, not r squared, and that's 0.86. And we want to know, what does that mean? Well, that means as the number of sunscreen let's do the number of ice cream, pints sold increases, so does the bottles of sunscreen. Because we have a strong positive correlation here, that means as the number of pints sold increases, so does the sunscreen sold. All right, letter D says, a new Kroger store just opened up and their manager has set a goal to sell 600 pints of ice cream. Predict the number of sunscreen bottles that Kroger should be prepared to sell. So if ice cream is X, that means we're plugging in 600 for X. So we get y equals 0.57 times 600 minus 94.6. And we're typing that into Desmos. So 0.57 times 600 in parentheses minus 94.6 gives me 247.4. All right, it says, after looking at the data, Kroger decides to put pints of ice cream on sale, hoping that it will also entice customers into buying more sunscreen. Do you think this will work? I want you to take a minute and think. Do you think this will work? Will putting ice cream on sale cause more bottles of sunscreen to be sold? All right. Putting ice cream on sale, I would say no, it's not necessarily going to cause more sunscreen to be sold. there's other things or other factors that are causing the correlation. And what I mean by this is there's something else that's probably impacting this. Think for a second, and maybe you already thought about it. What could be causing ice cream and sunscreen to be sold? It's more likely than not that it's the sun or the temperature. Outside that could be causing both of these things to be selling. The number of ice creams being sold is not really impacting the amount of sunscreen people are buying. And this is the whole point of today. So we want to talk about different types of relationships. Some relationships can have strong correlations, meaning we get an R value of 0.8 or higher, but it doesn't mean that they actually have a relationship that's related. We would say these relationships have correlation without causation. Typically, this happens when there's some hidden variable. So for example, I'm going to scroll back. The first thing we looked at was the number of sunny days and the cases of sunburn. Well, sun does cause sunburn, so those would have what we call causation. Where, same thing here, there was a correlation between number of ice cream pints sold and sunscreen bottles sold. But really what's impacting them is the sun or the temperature outside. They don't directly cause each other in that correlation. So what we want to do is we're going to look at a couple examples and decide, is there a hidden variable? Is it correlation or is it causation? And what I always tell myself is to have causation, it must always cause the other thing. If it's not always the only cause, then it's just a correlation. It just has some sort of relationship, but there could be other things impacting it. So let's take a look here at some examples, and this is what you're going to be doing in your homework today. So number 3 says, the number of miles driven and the amount of gas. Does the number of miles driven always impact the amount of gas you've used? Hopefully you're saying yes. The more we drive, the more gas we use. The less we drive, the less gas we use. A person's income and their blood pressure. Does someone's income always impact their blood pressure? That would be no. What are some other things that might cause that? See if you can come up with something. What could cause their income to impact their blood pressure? Maybe their job stress. Maybe if they make more money, their job is more stressful. Okay, a child's height and their vocabulary. Does a height always impact their vocabulary? The taller you are, do you know more words? And this one would be no. This is not a causation. This is just a correlation. What would probably impact this more likely is the age. Maybe you're older, so you're taller and you know more words. But just because you're tall doesn't mean you know more words. All right, number 6 says the amount of rainfall and the water level in the lake. Does the amount of rainfall always affect the amount of water in the lake? This one we're going to say yes. The more it rains, the more water there is in the lake. So these do have causation. So if one always causes the other, we call it causation. If there's something else impacting it, we call it a correlation. And that is it for our notes. You guys are going to practice this more in your homework, and we will go over it tomorrow or Wednesday to make sure you know the difference between the two.